Hey there, everybody. We are live according to the little indicator light over there on YouTube, LinkedIn, Twitch, and on Zoom. So good morning, good afternoon, good evening, good night, wherever you may be. It is Thursday morning, 9 a.m., and you know what that means. It is time for OpenCV Live, episode 202, if you can believe that. We have a fun one in store for you today, a little... I guess you could call this something from the Big Vision Skunk Works, the secret projects department.
Right.
I think this is something we discussed at the OpenCV team meeting a bit as well. And so it'll be fun to see that come to fruition. The code reviewer, an AI assistant for streamlining pull requests is our topic today. But before we get started, as we do on every episode of this show, we want you to tell us where you're coming from as you join the show in the various chat systems that you're watching it on. And let us know where you're watching. I'm coming to you from beautiful, fragrant Soma in downtown San Francisco, California. And our stalwart host, Dr. Satya Malik, is joining us from
San Diego, California. And it's nice and sunny, almost summer here.
And Abhishek, where are you joining us from?
I'm joining from Bangalore, India.
All right. It is an international affair here on OpenCV Live this Thursday morning. Over on Zoom, we've got Howdy from New Jersey. We've got Nevada, Texas. We've got Carlos sending hugs from Baja, California. We've got Tim from Tucson, Arizona. I assume Tim is a regular human bartender. We've got Israel, Everett, Washington, Vancouver, Bangalore, Bali. It's midnight in Bali. It sounds like a hit song from some era of a bygone time. Bruce Wright from Calgary, Alberta, Canada. Bill Blair says he's been having withdrawals from missing his OpenCV show. All right, we're back. We're here. We've got Puerto Rico. We've got North Carolina. Got the UP. We've got New York City on LinkedIn. The UP, the Upper Peninsula of Michigan.
Oh, okay.
That's how they talk up there. The Upers. We've got Colombia. Double check that we're good everywhere. And it looks like we are in fact live. Okay, cool. I think now is a great time to get started. Satya, you want to kick us off?
Yeah. Hello, everybody. Welcome to OpenCV Live. I'm Dr. Sasha Malik. And today we have a very fun episode for you. And this is about how internally we are changing how we are delivering OpenCV to you. So with me is Abhishek Gola today. He is one of the members who one of the engineers who actually work on the OpenCV code base, right? So he's part of the OpenCV team. But technically, he's part of my other company, Big Vision. Big Vision has a few people working on the OpenCV project. So that's how he's part of both the teams. Now, this is a very exciting. It is going to be an exciting episode. I mean, it's we cannot show you a live demo, but it is going to be very exciting because things are changing. In fact, in the last 15 days, I have been what is called vibe coding, and I have created a bunch of apps. But the same idea we wanted to bring into to OpenCV development because we, OpenCV 5, it's still under development, and we have a very small team that is trying to push it forward. So we wanted, and because of this, even code reviews, etc., right? People contribute code to OpenCV, and it takes a long time to review the code to make sure that it is in good condition, and then we can merge. So, but a lot of that work is actually some of that work, right? Let's say we get 50 or 60% of our code commits that we get from the community. They are not that difficult to review, right? But we have a small team, and that makes it challenging. So we built something fascinating where the code review is done semi-automatically, right? And Abhishek is going to talk about it today. But before we go there, as always, with me is Phil Nelson, who is the Director of Content and Creative at OpenCV. Phil produces the show, and if anything goes wrong, it's his fault. Hi, Phil.
Yes, good morning out there, everybody. It's PHI-LLIP. I am your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only. You know it's Mr. Nelson if you're nasty. But you, my dear friends, can call me Phil, and I'm here to remind you of a few things we do on every single episode of this program. We're on episode 202 of OpenCV Live, if you can believe that. The first is a giveaway to you out there in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on today's presentation, and the very first person to answer that question correctly will win the OpenCV University course of their choosing. Stay tuned for that in about 40 minutes or so from now. We're also taking questions from you in the audience. Use the chat system wherever you're watching. We're live on YouTube, LinkedIn, Twitch, and Zoom. Post your questions in the chat. I'll be monitoring those, and we'll bring the best ones up on screen later on in the episode. Before we get started proper, though, there's a little bit of business to take care of at the tip top of the show. First of which, Embedded Vision Summit is coming up soon, and there is a big deadline here. So Embedded Vision Summit is an amazing conference that OpenCV has been to, I think, each of the last 5 years, something like that. Satya has given several presentations there. We've attended and been participants by getting a booth, and always meet really cool people, and we see a lot of our friends there. This year, however, OpenCV is taking it one step further, and we are actually curating a track of speakers and some workshops here at Embedded Vision Summit. Satya, you want to talk a little bit about what's coming up at Embedded Vision Summit?
Yeah, so let me talk about the workshop first, right? So we are doing several things at Embedded Vision Summit. One is we'll have a booth. We are also managing a track, which means that we have curated the list of speakers who are going to talk there. We are managing, that thread. But we are also doing a workshop, and that workshop is on vision language models. I will be actually doing both the workshops. This is a live. Think about those workshops as live courses, right? So they are divided into two parts. The first is an introduction to vision language models. Last time when we did this, they do an independent feedback from the people who attended, and I think my rating, I cannot remember the exact number, but it was something like 97% or so. And I still don't know why some people held out. but it's a they take a lot of effort to make it really polished. So I had to go through 3 rehearsals for the last vision language model course. So this time we have split it into 2 because things are moving so fast and there is so much to cover compared to last year that we have split it into 2 parts. The regular one, an introduction where you learn about how vision language models work, right? How do you combine the vision part and the language part, right, into a single model? And then you will also learn in the advanced course, you will learn about how you can use it for video analytics or video analysis, and how you can use it for agentic reasoning as well. So it's going to be really fascinating because I'm putting a lot of effort into both of these courses. So please visit us and join this. If you're in the Bay Area, definitely do it. And you can also, if you need help convincing your boss, Embedded Vision Summit also has a section where you can actually copy their format, right? Just to convince your boss that this is a good conference, and it is. So yes, that's Phil. You can talk a little bit more about the booth as well as the talks that are going to be in that conference.
Yeah, and folks can check out last week's episode, which was a whole deep dive into this coming year's Embedded Vision Summit. OpenCV will have a little booth there as well. We've got I actually got an email from one of our friends that watches the show that their booth is actually going to be next to ours this year. So that'll be fun. It's always good to know your neighbors, I say.
Right.
And as a reminder, this is in Santa Clara, California. It's easy to get to through the Caltrain or the BART if you're in the Bay Area. And going to these conferences, especially going to the conferences that OpenCV has a direct relationship with, like Embedded Vision Summit and Display Week, is another way that you can actually support OpenCV. It's not necessarily intuitive, but by attending these things that we do, it gives us a little bit more cachet to say to people, hey, you should be working with us more and giving our community free stuff. And so please join us at Embedded Vision Summit. It's going to be a lot of fun. We'll have the big OpenCV banner backdrop if you want to come take a selfie with Satya or myself, or possibly Mr. Bradsky will be there as well. So it's going to be a great time. Join us May 11 through 13 in Santa Clara, California for the Embedded Vision Summit. There is a discount code active right now. It expires tomorrow. So you want to use that code, 25% off registration. You can grab that code in the chat wherever you're watching. I just posted it in there. Use that code before the end of the day tomorrow to save 25% on Embedded Vision Summit. We also have Display Week. OpenCV is bringing back our one-day conference, OSCA, the OpenCV SID Conference on Computer Vision and AI at Display Week 2026 in Los Angeles, California. That's right, somehow, some way, they've got me to return to Los Angeles. I don't know how they did it, but I'll be there, and you should be there too. Display Week is the largest gathering of display professionals and technologies in the entire world. I think last year was between 8,000 and 10,000 people. It was amazing. It was a great experience for us. It was my first time being at Display Week. I think it's true for Satya as well. It was in San Jose last year. This year, we've got an entire day for OSCA, a workshop from Satya, as well as 6 speakers. We've got Gary Bradsky, OpenCV founder. We've got Sean Frayne from Looking Glass Factory, who just released their awesome new mini display, Musubi, on Kickstarter. They passed like a little over 100K on their first day on Kickstarter. Congrats, Sean. We've got a bunch of folks that have been on this show and people that will be on the show in the future at Display Week. So please join us in LA, scan that QR code, and register for OSCA, and we will see you there. We'll have stickers and pins and stuff for attendees. We'll also have the AI pavilion on the show floor, the exhibits for Display Week. We'll have an 86-inch holographic 3D display from Looking Glass. It's a life-size, person-size display that shows you stuff in 3D. Like, you can move around it and it moves with you. It is extravagantly cool, and we are very lucky to have them with us this year. And you can come check it out at Display Week. So please join us for Display Week. But enough of my yapping. I think now is a great time to start the presentation. Abhishek, you ready, buddy?
Yes, sure.
All right, let's do it then. There you go.
So today it's about the code reviewer, AI-based code reviewer. So I'll just keep going in this, and then we will talk a lot about this AI-based code reviewer. Why is it needed? How we are going to do it? What are the models that we are using? How we are linking it to GitHub? That's all we are going to talk about. So I'll just move ahead. First with my introduction. So hi everybody, myself Abhishek Gola, and it's been more than 2 years since I have been working with Big Vision as a computer vision engineer. My goal is to provide end-to-end solutions, including research to all the way to production. My expertise has been around 3D vision, localization, reconstructions, and SLAMs. On the part of OpenCV, it's been quite a few times since when I have been contributing to OpenCV. Like more than 50 pull requests I have submitted in OpenCV. Talking about some of my impacts. So when I joined OpenCV DNN, it was having 22.5% ONX coverage, and now it's 75% with the collaborative effort. I introduced initial Coda support in OpenCV 5.x in new DNN engine. Other than that, I have also added ONX runtime as an optional wrapper for those models which are currently lacking in OpenCV 5.x in new DNN engine that are now supported as an ONX runtime optional wrapper. So we have provided both CPU and GPU based wrapper. Currently, we are working on adding transformer based wrappers too. So that's on OpenCV. Going about, I'll just skip it. So going about today's topic, that is AI-powered code reviewer. So what is the motivation behind it? What is the vision behind it? And what are we going to achieve from this? You see, like in the evolving world, we need to evolve too. So currently, we have started this in OpenCV that there is some work going around. So our vision is to add a AI-based code reviewer, which is much more than a basic syntax checking and lint checking. Other than that, it should be a digital peer to human-like feedback system. And moreover, as OpenCV grows, you guys as a community member will also grow, will also contribute. So it's humanly not possible to review everything at the same time. So we can partially automate that part. And why is it needed? So let's talk about that. There are few challenges as a developer and a reviewer I face in OpenCV and anyone in the core team also faces. As you see, there are tens of PRs that are getting raised daily basis on the daily basis in OpenCV. So that is a massive number to review with such a small team. And there are some PRs that are AI generated PRs. They don't follow OpenCV's code structure. They do the coding. We appreciate that and we encourage them. But there are some things that are not followed in the proper way. So to review that part, it's time taking for us. So we can automate that part by, as we have predefined way how to code in OpenCV, what is the format to that, and what is the structure to that. Even if there are some new features, the bottleneck is we need to test it every time. So for basic things, the thing can be done for now is automated. So like for these things we can automate with a AI based reviewer that this is not the correct format, you can use this format, and this is not the correct place to edit the particular amount of particular type of code from here. So to test it locally, it takes a lot of time. Sometimes even more than the people take in creating that PR using AI. So it is
Often.
a maintenance fatigue.
Yeah,
Yeah.
yeah. It's like sometimes I get these questions on LinkedIn. Uh, can you please give me career advice? Right. It is like it will take me 1 hour to write the. It took you like 2 seconds to write the question. It's going to take me 1 hour to write the answer. So sometimes you get those kinds of pull requests that takes more time to actually verify that the answer is correct than the
Yeah.
person who actually spent in the pull request.
And
Uh,
often
Yeah.
it actually takes longer to explain to them why they're wrong than it did for them to write the code.
Right. Right.
right.
So the
And
issue is, yeah. Continue.
yeah, go ahead, Abhishek.
Yeah. So the issue is like whenever they are creating a PR, the change is so technically deep that you need to review it technically and test it on like deep basis. But when you figure it out that no, it's not making sense, then you need to like compile it why it is not making sense, explain them, and that is a long process. Then like it is more than twice of the time they took to create that PR.
Right. So, I mean, think about OpenCV. It is such a sophisticated library, right? Think about what it takes. Let's say somebody is making a change to the OpenCV library, and we have to make sure that nothing breaks, right? We cannot, from release to release, things cannot break. Otherwise, it will be a disaster. Like, if we release something which is not, if it breaks something, we'll be getting calls from Google, from NASA, etc. Maybe we should do that and ask them for funding, but we don't do that. But if so, it becomes very difficult. Think about what an OpenCV maintainer, the qualification, right? First of all, they need to be very good at C++, right? And because the library is written in C++, they need to be excellent in C++. They also need to understand processor level optimizations, right? So OpenCV, for example, runs differently when you have an Intel processor versus when you have a GPU, etc., right? So there are different paths, and there are very sophisticated optimizations that are done under the hood. You don't even know, you're calling the same function, but based on whether you are on the CPU or the GPU, etc., it basically uses that hardware acceleration to do the job, right? So that is why OpenCV, you need that expertise. And then you need algorithmic expertise, right? Let's say somebody is saying that, oh, I have improved this algorithm. Well, first there are 2,500 different algorithms implemented. You need to have a good grasp of how this algorithm is changing, and what they, even if in the best case, even if their the test code that they have written, it is reproducible completely, even then you don't know the implications downstream. What are the other what are the other trade-offs that they have made, right? Which is not obvious in the pull request. So you need to be good at C++, you need to be good at hardware level optimization, you need to be good at software understanding of the algorithm, etc. So it is difficult, right, to accept a pull request. The easy part, though, is there are some pull requests which are just badly formatted, right? So you have to tell people to put it in the right format, and some of that load can be taken away by these agents or reviewers.
It's sort of like the old Homer Simpson quote about alcohol. To AI, the cause of and solution to all of life's problems.
Right. Right.
Yeah. So, like moving ahead, as Satya mentioned, it's a vast library. So, like keeping track for all of it is humanly like not possible. So, whenever you are reviewing that PR, it takes you time, and that time-taking process can delay some genuine PRs. So that can pile up and create a baggage. So to help that out, we are trying to get rid of this challenge with a basic AI code reviewer that will do like that can filter out 60% of the PRs that it has some visually like some basic issues that we can rectify. So that would provide direct comments. And once that's done, they are worth reviewing for the developers. Moving on next. So, as I mentioned earlier, it's not just a simple or a standard linter check and static analysis that we are doing in the CI pipeline. It's more than that. The goal is to understand the OpenCV's code structure, the coding style, and the whole detail of OpenCV. Then create a tailored solution that is exclusively for OpenCV environment, for OpenCV ecosystem, and that understands the OpenCV code well. That's what we are going to do here. Let's say a PR is getting raised. So there would be a call from an automated PR reviewer, which is based on QWEN 2.5 quarter 7 billion parameters model that is fine-tuned by us on OpenCV's code and comment from OpenCV developers that review feedback. What it does, it analyzes the PR, understand the code, takes that context and check if it is hitting some parameters or not, if it is under the hood or not. So if it is good, then it passes it. If it's not, it provides human like reviews that no, it's not the right place, no, it's not the right format. And going ahead, so why did we choose QWEN 2.5 quarter model, that too with 7 billion parameters? So the coder model, QWEN model, it is open source, easily trainable, and specialized in programming languages like C++ and Python. And most of the OpenCV code is in C++ with Python bindings. So that is a easier choice for us. Also, the 7 billion parameter number is Goldilocks. That not so low, not so high. It is faster enough and easier to train. Not needs to be have a such bulky machine. It can run on a decent machine, and it can take a larger context of video, larger context of payload, that is PRs, and the context of that PR using reg systems. Also, and there can be some better choices like GPT and Gemini, but those API costs for such big number of PRs can be a very difficult choice because they are very costly. So training in-house model is the correct choice. That's what we have chosen. The basic functionality I will explain you here. So what we do, let's say you raised a PR, and then it will automatically like do a slash review a comment that would review the whole patch, take the context, and provide you the feedback. For now, it is manually that you need to type slash review, or it has other two options as well, slash improve and slash ask. In review, it just provides you simple feedback if it is good or not. If there are any issues, it will point you out. In improve, you can ask it to give you some suggestions that how can I improve it, what should I change in here, and if you have some general query as well, we have a slash ask option that you can raise it on your PR and ask the feedback. Once it's done, it takes the code diff and passes through our LLM fine-tuned model on OpenCV reviews. Based on that reg system, we ensure that the code context that is given is like relevant to the PR changes. Otherwise, it can, like, OpenCV code is a lot bigger, so it can move around and waste time. So reg systems are really important here. I'll just go through the flowchart here. What we do, once PR is raised, we manually comment slash review for now, and then using that webhook, it goes to orchestration where it filters out what context needs to be taken. Once that context is taken, it augment the prompt and give it to the QWEN model, that is QWEN 2.5, currently hosted on RunPod. It generates the review and posts it on GitHub PR, and that all, like, communication between PR and RunPod is done with PR agent, that is a CLI option that can comment on your PR and provide the feedback. Moving next on the part of training data and preparation. So, like, a simple model cannot do this job. We need to fine tune it, and as OpenCV has a big library, and we must need to fine tune it. So, what we have done, we have fine tuned it on the OpenCV 4.x code and pull request reviews from OpenCV maintainers. And once that context we have, we took all the data, trained, fine-tuned a QWEN 2.5 model that with 7 billion parameters, and it took around 16 hours of training time, and we were able to achieve that performance that we expected.
What kind of GPU did we use for this 16 hours of training?
It was 48 GB GPU L40.
Okay.
Yeah. And
it was locally done, or it was a cloud instance?
it was a cloud service for training, and we used RunPod for that.
Okay.
Other than the code, OpenCV documentation is like plays a much important role. How the formatting should be there, that we all explain here, but nobody follows that while raising PR. So we have taken that into context, and using reg system, that is quadrant, we take the relevant API references, inject that into the QWEN model, and get the review generated. So like, it needed some data filtering before, because from the experts as well, there are some PR comments like looks good to me or approved. These type of comments need to be filtered out, that we have filtered out. Moving next.
So it may be a good idea to just briefly explain RAG here.
Yes.
right? And why do we need it? So basically, if you're training a large language model like this one, right, there could be some documents either it doesn't have access to or it doesn't emphasize, right? So out of the box, it works fine, right? But you need to direct its attention to your internal documents, right? So even though this is public information, right, OpenCV documentation is public information, but it may not be paying attention to those documents while answering the question. And our goal is that no, you focus on this, right? So in that case, you basically build a RAG system. So whenever you want to train an LLM, it's a very large, an LLM could be very large. Um, so, but you want your own personal knowledge, right? Private knowledge, or even you want to emphasize something. In that case, you use something called retrieval augmented generation, right? RAG. Here, you basically have a collection of documents that you want. You convert it into a vector database, and it looks whenever you ask a question based on the question, it may go and look inside this document first before using its world knowledge, because these LLMs have their own world knowledge. They know a lot, but they will give emphasis to the documents that are in that you trained using RAG. So that's one thing. The second thing is, how do you train these large language models, right? How do you, why doesn't it take, how can a 48 GB machine train something big, right? The answer is that, LoRa embedding, which is basically low rank adaptation. So imagine that you have a big, inside these models, you have these big matrices, weight matrices, which are very large. Like the numbers are millions, right? Million by million. So think about a matrix, which is a million by million, right? And I'm just taking this example. A low rank adaptation of that matrix would be that you can also have two matrices, right, which are let's say a million by 100, and then you multiply, and then 100 by million, right? So when you multiply these two matrices, you get a million by million matrix. A million by million matrix has 10 to the power 12 parameters, but a million by 100, two of them would have 2 times 10 to the power 8. So that you can see how the orders, by orders of magnitude, the number of parameters that you need to train for fine tuning goes down, right? So that is the beauty of LoRa. And the idea is good. Oh, you did this matrix trick, but in practice, people have figured out that it actually works very well, right? This low rank adaptation of because the model already knows very well, right? It knows what it knows how to it knows a lot about the thing. So the weights that need to be updated, it's only a minor change, right? It's a minor step, and you can suddenly get things working much better on your private data, right? So that's those are the two things that are relevant here.
Yeah. So, summarizing what Satya said.
Abhishek, you want to add anything about like what was used in our RAG
Right,
and
right. Yeah. So adding on what Satya said, I'll just summarize it in context of OpenCV. Let's say you are adding a layer, ONX parameter layer, that let's say non-mix suppression layer, and you need a review in that. So why we need RAG system here is OpenCV is a big code base. So we have a quadrant vector database that has summarized it in its own way. So when PR is raised, the particular change is non-max suppression layer, let's say. So to provide feedback to that, if we are going to reiterate the whole OpenCV code, that's gonna take a lot of GPU memory and a lot of time. So here rec comes in the play. What it does, it take that context. Let's say I have a non-mix NMS layer, and it will pick that changes related to those files it will pass to quadrant, and that will give it the context. Oh, it's relevant here. You can pick these changes. Once these changes are picked, now we have much smaller context rather than having full OpenCV code base to scan with. So it will be much faster, lesser GPU memory. It will pick that changes and like look into the context. Is it done correctly? If yes, then it's good. If no, it will provide the feedback based on our fine-tuned model uh, that we have done. Once it is done, we are good to go.
Thanks for that.
Right.
So I'll provide some examples for you. This is the exact thing I was talking about, the track systems. Here it comes into play. So I will first open the PR. And this is a dummy PR that I have raised. So let's talk about the context.
Quick
It
shout out
has
to
some
FFmpeg, the goats.
Right.
yeah. So it was having some changes related to uh, FFmpeg and some video related things, and it is a random sample that I have put just to test how does it work, and it has some tests. So it has taken a context of first of all FFmpeg, and some metric multiplication were there, array operations were there, so and img proc operations were there. So it has taken context of that. That's what rec does. So what it did here, it picked the changes, figured out which file it is using, what are the function it is using, and then it checked it to its vector database, that is quadrant, and it queried it. It was able to figure out, oh, these are the concerned files that I need to check, and this is the concerned line of code that I need to check. It took that constant context for all the files, then combined it and passed it to QWEN model. I have this context and this is my query. What can be the results? Is it doing it in the correct way or not? Please provide the feedback. That is all the things happened internally.
Yeah. So the QWEN model doesn't have to look through the entire code base,
Yeah.
right, which is very large. It just needs to focus on these files for this pull request, right? Because yeah.
And on these files also, these are very big files, up to 2000 to 4000 line of code. So taking whole at context would make it worse. So we need to cherry pick the changes as well, cherry pick the context as well. Like I need to take 40 lines in the consideration, 50 lines in the consideration. These functions are used. If it is connected to something else, I'll pick that again. But for now, this is what I need.
Right.
Once context is done, it is passed to QWEN model. It will provide you some feedback. So in this case, I'll show you.
And this system is actually live right now, right? It's been live for a few months.
Yes. So if you see here, it is able to locate that there are some possible memory leaks. You need to check into that. Also, I intentionally put it that it has a hard-coded path in it, so it won't work. The cache handling, it's not there. So these are the, if I am going to review it, it will take me 5-10 minutes. But if it is like I need to open the PR, check it, and then provide some comments. To make my job easier, we have this, it can do some obvious things and some non-obvious things like memory leaks and all. It is not easy to catch with eyes. For that, I need to run address sanitizer, check if there is any memory leak. If it is not caught by code, I'm not able to see it in the code, then I need to run address sanitizer. Then I will be able to catch it. So we have a merit in here that, yeah, it can do this job for us.
Yeah.
Yeah.
Yeah, I'm looking at that code, and it can easily you'll easily miss this, right? Unless you
Right.
actually run the code. By looking at the code, you will miss the memory leak, right? Easily.
Right, right. So, for me to manually test it or anyone to manually test it, we need to first run address sanitizer. Like before that, I need to clone OpenCV, build it from scratch, and with address sanitizer, then run that specific test and check for all the possible memory leaks. Then I will be able to catch it, and that's a
Yeah.
hectic task that's not done in 5 minutes. So I will be spending
Right.
1 hour in that, but it is done in like few minutes or few seconds here, so that's saving a lot of time.
Right. And we still, I mean, of course, we have human reviewers look at this code once it has been pointed out,
Right,
right?
right.
So it's not like we are automating the whole thing.
Yeah. So just to clarify here, it is for checking the first review. It is for it would be the first reviewer. Then we wouldn't require a manual approval from OpenCV maintainers. If it looks good to them, then it is good. So it has multiple checks. First, it is the CI checks. It is done for most of the devices. uh, we are also adding address sanitizer and all these functionalities in there. Then there would be a second round of review that it would be done by AI reviewers. Once it is done, then we will do manual review for from OpenCV maintainers. It is usually done by two people, so there is no scope of anything going past them, like passing them. So it's we are not completely relying on this. We are just taking help from it.
Right.
Just a minute. So this is another example. If you see, it is able to provide that input validation is not there. So we need to check if we are not getting, like, if there is any possibility of getting empty input, then provide a check here before like adding it to the consideration. We need to check input is there, then we can move ahead. And in the second case, uh, we have added the GRE layer, but there is this is the deny list. So what deny list does, like for now we are not able to support 100% of the ONX. It is 75%. So whatever operations are not supported, we add it to deny list. But if you are adding support for any of those operations, then you need to remove them from deny list. That's why it's triggering missing tests. You need to first remove that from deny list, then it will be able to run those tests. Otherwise the pipeline is broken, it's not testing those tests. So it's doing a quite good job, yeah, to be honest. Uh,
Yeah, this is super helpful. I mean, you're fighting AI with AI.
yeah,
Yeah, so long as they don't
and
start collaborating, we're all good.
That's right.
yeah. So this is another PR. I'll just sorry, just give me a minute. So it was an actual PR that was adding alpha mating sample to OpenCV. So it was able to figure out a few things. Just let's say it is just loading the model but not checking if model is already loaded or not. It needs to put a assert that yeah, after loading there was not any error. Model was not empty, it was able to load successfully. And also in here, so there are some unknown arguments which is not shown here, but it was there in the lower code. Sorry. Next, how do we set up it on like using a local server with GitHub. So there are two possible approaches. One is GitHub provide personal access token that you can use for local testing. You can allow access to that token, read, write, and access to your PR and issues. Once that GitHub token is generated, add this to your env, and this is the format for that, and you need to add your repo on which repo you are trying to apply. There is an option while generating the token that if it is valid for all the repos or not. Once that token is done, there are two ways for there are two ways. So I personally prefer the second way. You can create a multi-tenant access for with this way. Just in this way you will create a .pem key which has access for read, issue read write, and PRs read write, metadata read. Once that pem key is generated, that is private to you, you can install that app in the GitHub. That will connect you with the webhooks. So there are two options: install in the single repository or for all repositories, or you want to keep that app private or want to make it public for everyone. Once that is done, you need to set up the webhook. For that, as we are testing on the local server, so we have secured it using ngrok. We run the ngrok, provided that url, and added that to webhooks in GitHub Actions. Once it is done, then we need to run the dockers on our local. The server is ready. We are ready to use that service. Like, put the slash review, you will get the review. Put slash improve, you will get the possible suggestions. And for any query, you can put slash ask. And this was for connecting GitHub webhook with that app. Other than that, we also tried uh, a real-time ID feedback and expanded capabilities. So what it did, like as a user, when I'm coding for OpenCV, rather than raising the pull request, if I am getting that feedback real time with my extension, that would be really good for me. So we have created an extension for that. I'll show you. First, I'll show you how it looks. So this is an extension. I'll just provide my code. Like this is I'm changing, and here I'm changing. Please provide me the feedback. So we have used a continue extension for that, in which you can provide the access to your own model. You can see down here OpenCV PR reviewer 7 billion plus auto-rec model. So we can add our model to it, and once it is added, it will use that model to do all the testings. So what is it? It is a live VS Code extension. As I mentioned earlier, all you need to do is give your context. This is I'm changing. In this file I'm changing. A small context is enough. It can use the reg system to get the detailed context. It will provide you the live feedbacks that if it is going right, it's good. If it is not, you need to improve this. It can like if there are any style violations or architectural issues, it can like alert you before raising the pull request. Once these things are done, it is a much smoother process for you to follow the OpenCV guidelines and raise the pull request for that. This thing can be done for anything. It is not limited to OpenCV, any PR or any repository. It's good. You just need to scrap that, train that. Once it is done, you can integrate that. As I mentioned earlier, we trained our model, then integrated it in VS extension using continue. That is an option where that is an extension where you can provide any model or use any of the other models. You can also like us, you can train your own model and provide context there that will use that model. And it is like how it has changed from GitHub webhook. So this like kind of version 2, where we increase the context, increase the like more formatting is introduced in it. Training was like it was trained for more time, longer time, and we expanded the data by like adding support for OpenCV 5.x as well. Created the trigger boundaries. Once that's done, we trained it again, and it was much better with VS Code extension. That's it.
Excellent.
Anything?
Yeah, tell the folks about these freebies here, Satya.
Well, we have this document. It's basically about common pitfalls while building AI applications, AI projects. So yeah, there's some interesting ones there that people may not recognize. For example, sometimes there is something called leakage, right? You are able to get much better results on your test set, but not in the real world. And one of the reasons could be that some metadata has leaked into your into the training somehow, right? And that metadata is actually helping you get much better results. So how do you detect that has happened? I'll let you download this, right? So those kinds of things you will learn about this. And this, Big Vision is our consulting company, right? It helps OpenCV, but it's also a consulting company on its own, right? We have been around for about 15 years. We have done several projects, about 200 plus projects, and we have worked with about 100 plus clients, 104 to be exact. So yeah, if you're looking for an AI consulting project where you need to build something and you're not able to do it, then please contact at contact@bigvision.ai. And if you have a problem that you need help with, a commercial problem, you could basically book a meeting with me right there, bigvision.ai/book15. So it's a 15-minute call, but I'll do my best to answer your questions. And hopefully, this if you need more time, we can schedule another call. But 15 minutes should be enough to give you guidance on which way to take. People in the past, they have used it. The last person I talked to in this 15-minute call was using an object detector to solve a problem, which is actually a segmentation problem. So let's say you have an object which is very, it moves around, the shape is like long and thin, and you can detect it, right? A bounding box, but in that bounding box, only a small portion of it is covered by the object. So those kinds of problems are ideally solved using a segmentation problem, and that simple thing I just suggested them with some solutions. So that simple thing helped them quite a bit, because as an object detector, they were not getting. They were getting the object, but it's not enough. They were not getting what they wanted to do. So yeah, if you have any computer vision problem, or your team is struggling with a computer vision problem, so you can book at bigvision.ai/book15.
Yes, indeed. I encourage you to do so, everybody out there. Now is the time for our trivia giveaway. Just when you think you've got all the answers, I change the questions. So the way this works is, rest in peace, Rowdy Roddy Piper. The way this works is I'm going to ask a trivia question based on today's presentation, and the very first person to answer that question correctly will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. But first, I'm going to remind you that this show is brought to you by the Intrinsic AI for Industry Challenge. This is an ongoing challenge, $180,000 prize pool. The AI for Industry Challenge is an open competition for developers and roboticists who want to tackle some of the hardest, high-impact problems that exist in robotics and manufacturing. Join a team before the deadline of April 17th, the registration deadline there, and you can win a part of that $180,000 prize pool and, of course, importantly, bragging rights. Join the challenge at intrinsic.ai, or you can scan the QR code on your screen right now. They've got a gangbusters evaluation committee here with some of the top names in the industrial robotics field, including folks from NVIDIA, Universal Robotics, Google DeepMind, Open Robotics, Intrinsic themselves, and Foxconn. It's something you really want to be a part of. Satya, you want to tell folks why these competitions are important to join, even if you don't win?
Well, as a beginner, you have to start somewhere, right? When you participate, you get access to all the data set, etc. So you get started on the problem. You start thinking how are the various ways of solving the problem. And it's a serious deadline. It's not like, oh, I'll do it in 6 months, right? So it's a serious deadline. And if you've never participated in these competitions, you'll be surprised how much you can accomplish in a very short period of time, right? And of course, if you are a student who is graduating, or if you are a person who is looking to make a career change, if you participate and win the competition, it's a big badge of honor, right? You have something to show off. People don't care when you say that, oh, you have done this project, that project. When you say that you have won the Intrinsic Challenge, that's something. It's a Google company. There are $180,000 in prizes. So people will take notice immediately if you are, if you're in the top 5, top 10. So please take it seriously, participate. It can change the course of your career.
Absolutely. Well said, Satya. Thank you for that. We are going to do it. So if you've won in the last couple of months, please don't answer and give someone else a chance to win. And please try to hold your answers until I actually read the entire question. So we built a model today. We fine-tuned a model. What base model was used to make this tool? The full name of the model, including the number of parameters, the full name there. And we got Erkan, I think. Erkan on Zoom immediately got the answer, which was QWEN 2.5 coder 7 billion parameters. Congratulations, Erkan on Zoom. Please send one email to me, Phil, at opencv.org. That was extremely quick. Erkan is very happy in the Zoom chat. I can't share the screen there, but he's very happy. Congratulations.
Nice.
Thank you for once again absolutely destroying the trivia segment of the show. I appreciate it. So we've got a few questions here. I think now is we've got a few minutes left for questions and a few questions, so it's going to work out great. Uzair, I believe is how to pronounce this one. Uzair on Zoom asks, how are the files added through RAG relevant to the PR review? How do they help the LLM? Could you please go over that once again? Thank you.
Yeah, sure. So let's just consider you have changed in a few files, and what RAG does, it has already the context of whole code base. So it has vector embeddings in its vector database. Here we use quadrant, so it had all the context. So what it does is picks the difference of files. Like in this file, we have these difference that you see from git diff. It takes that, that is the query for the system. It runs it over its vector database. Then its vector database returns some, like, this is the most confident answer I can give. This is the context I am getting. These files are the concerned files. You should look at here. Once that data is like we get that data is passed to LLMs, and LLM has a much bigger context now rather than giving it a smaller context from the PR or giving it the whole context of OpenCV. So it has a quite decent amount of context, not much is called smaller and not so bigger. Once that context is there, it passes through the fine-tuned model. It knows what does the structure look like, how code should be done. It checks for any memory leaks, any possible missing checks. Once it is done, it provides you the feedback.
Awesome. Thanks for that answer. I think that.
So basically, it is used to draw the attention to the right places, right? We don't want it to look at the entire code base, which can be very, very large, and we want to find. It's almost like searching for documents that are relevant to answer this query.
Thank you for that. And thanks for the question there, Uzair. We've also got Valdarian SGS asks on YouTube, are there any guardrails implemented for the RAG output?
Like majorly speaking, it's based on the code base itself. So not many specific guardrails. So it was just a basic experiment for now, working around how it goes. So we haven't defined any hard guardrails right now.
Right. And there is, this is always in response to a pull request. And I'm pretty certain that GitHub, when it accepts a pull request, right, there is some sort of or when you create a pull request and when you try to, GitHub must have some level of sanitization, right, before it hits us. And this is a system which is not like a truly consumer facing, right? So it's not like, what's the worst that can happen, right? The worst that can happen is somebody is trying to do a pull request that is completely irrelevant. They are writing a poem and sending it as a pull request, right? And then it is going to basically output something which says this is not relevant, right? So in terms of guardrails, right, those if you're talking about guardrails which where you're concerned about the social impact, that those kinds of things are much less relevant when you're building a system for developers, and especially for internal use, which will be manually reviewed, right? Worst case scenario is that you delete the pull request.
All right, thanks for that. We've got that was actually you guys pretty much answered all of the other questions here. I think we can call it a day, unless you guys in the chat hit me up if you got any questions. We'll chill for a couple minutes here, but I think we got to all of them. Excellent work on the presentation, Abhishek. Really appreciate it. Thanks for coming back on the show and pinch hitting. I think you found out you were presenting today about 6 hours ago. Something like that.
Yeah. Yes.
Yeah.
We
the
had
person who was responsible. We were supposed to give a talk on SID, and unfortunately they could not make it. So we had to make this last-minute change. That's
right. But the show must go on, as they say, and you did a great job pinch hitting, Abhishek. So thanks so much for that. Yeah, Satya, you ready to call it a day? Why don't you take us home?
Yeah, thank you so much, everybody. Thank you, Abhishek, for the short notice and putting the presentation together. And thank you, Phil, for organizing the show. Nothing went wrong because we pulled it in the last moment. And thanks our audience for being here, for supporting us. So our goal with OpenCV 5, once it releases, so there are some bottlenecks, right, for releasing it. But once we release it this summer, I want to push for monthly releases, right? Right now, just to give you an idea, we have these releases which are bi-yearly, right? The OpenCV 4, after OpenCV 4, we have every 6 months, we have these releases. and we want to push it to about a month, right? But OpenCV 5 is a big release, so it's taking some time. Once that is done, we will use AI very extensively to add new features, etc. And hopefully, monthly release will be an option, will become a possibility even with our small team. So that's where we are. That's why we are experimenting a lot with these tools. So we'll see what the future is. And as uh, as Phil had mentioned, please join us in the various conferences that we are doing. One is in LA, the SID OpenCV conference, and the other one is in the Bay Area, Santa Clara. If you live in those areas, please visit us. That is one way of supporting us. Thank you.
Yep, absolutely. We would love, love, love to see y'all folks in Los Angeles or Santa Clara or in Denver, Colorado for CVPR this year. OpenCV will be there as well. And we will be back here next Thursday, same bat time, same bat channel. We'll be welcoming back Murtaza Hassan, who will be talking again about the PySimverse robot drone simulator, which was a really interesting episode of the show a while ago. They've been doing a lot of work on it, and he's going to come back and tell us a bit more about that. So we will see you next week. Take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. Adios.